Hello and welcome to this second lesson on star CCM plus. In this lesson specifically, we will look more into how to properly do parametrization and how to use the design manager to run multiple simulations one after another. So currently I'm in the 3D CAD. I've imported three parts, one large main wing, one small flap and one slightly bigger flap. And now I will show you how to an example of how you could properly parameterize these in a way where you could efficiently change one variable and you would have all the other wings properly follow. So what we're going to try to do is to have these wings appear right behind each other in a way where if I have a certain setting for the first flap and the second flap, but I change, for example, my angle of attack for the main wing, that the other parts will follow suit. So um, first things first, we'll be doing a couple transformations here, and the order of these transformations are important. If you do them in a wrong order, then your results will vary. So in general, it is always best to do the when you want the small parts, for example, you want these flaps, you want them always to follow the trailing edge of the previous part. So it's always better to first do the transformations on the main part. So for example, right now, the first thing that we will need to do is add an angle of attack transformation on our main wing. And so we will start by doing that. We'll go to transform, rotate, and we will, hang on a second. Let's make sure we do this correctly. Yes, so I will put this at 0 degrees for now. And I will make this a parameter. Expose, and I'll call it main wing away. Main wing away. Okay, and that should do it. So when I go to design parameters and I change this, you can see that if I do that, for example 15, close, and I rerun this. Wait, how do I get this to rerun? Nope, that doesn't do it. That doesn't do it either. How do I get this? Refresh, I'm sorry. No, that didn't do it either. Ah, yes, update model. All right. So now it has been updated and the rotation has been done. Now, hang on, my flaps are hidden in the part right now, but I'm going to turn this back to 0 degrees again. And I'm going to update the model. So now this is the first thing we have to do. It's the same thing we did in the last course, but now more complexly, you want these flaps to appear right behind it and to technically follow it. So a very simple way that can be done is to create a new coordinate system. Now, where do we want this coordinate system to be? I will show you how to do this. So what we're going to do is to create a coordinate system that lies on the trailing edge of this main wing. And then that way, that coordinate system will follow it when it is updated. So first, to create a coordinate system, we're going to create one by a point and an axis. So first, we need to create an axis. So to create this axis, you will select Create Axis from Linear Entity. This will allow you to click on an axis or a line in your drawings, and it'll define it as an axis. So that way I can just go OK. So now I have this axis over here, and now of course we still need a point. So we're going to define that point right now. I'll just go to create point, and you're going to want to create a point by offset. So what this does is you can select a point. I will select a point on this axis right here, and then I'll have to define an offset. Now you could select this offset to be 0, but then you won't be able to create a you won't be able to create a coordinate system. So I'm going to tell it to be in this direction. All right. And so this point is just 1 meter in the x direction from there, and that will be all. So then right now we're going to create a coordinate system, and we're going to create one from a point and an axis. And the point, you will select this point, and the axis, you will select this point. Importantly, you want it to be placed on the axis, and I seem to have placed the point in the wrong direction, as my y-axis is down and my x-axis is in that direction. But simply going into this point and redefining this to a -1 should at least fix this. Update model and update model. Yes, so now we have this coordinate system, and this coordinate system will always be parallel with the original coordinate system. So the x-axis and the y-axis will be parallel, and its origin will always be in the trailing edge of my first wing. So for example, if I change this parameter to, let's say, 15 degrees once again, I should really find where I could fast update this. Hold on a second, I'm going to look for that. All right, I found it. It's just up here. So if you click update right here, it'll update all these transformations at once, and then you can keep your work going. So for now, I'm going to change this back to 0 degrees as we continue the parametrization of our project. So next step is to actually transform. So you'll have these flaps, and we want them to appear behind this wing. So I will now transform flap 1. I will select transform, and you select the coordinate system. Once you are in this menu, you can here select to the coordinate system number 1, and that way you can just press transform body, and here you see this wing has now found itself right here. Now, of course, it's sticking. This is not what we want when we're actually simulating, so we're still going to add 2 additional parameters. We're going to add 1 translate parameter and 1 angle of attack rotate parameter. It's important that you always do the angle of attack parameter first, because that way you can do it right after the transformation, and you can select this axis as its rotational axis, which will mean that its rotation is always consistent. If you do the translation first and then the rotate, it'll yield inconsistent results depending on the way you do it. So always be sure to rotate first before translating. So we're going to transform, rotate. We're not going to rotate around this axis. We're going to nope. We are going to rotate. Oh, we can also just, it's easier that way. We can select this coordinate system we just imported into. This will lower our work. Oh wait, I accidentally I'm going to edit, and I'm going to select once again 0 degrees for now, and I'm going to expose this parameter as flap 1 AOA, and there we go. That should be good. All right, now we're going to translate it. I'm going to once again select flap 1, and I'm going to translate it. And that is once again, I'm going to select this coordinate system we have just created, and I am going to expose this vector as flap 1 xy. When you open this in the design manager later, I'll show you how these x, y, z will be separated, so that way it'll be easier to edit them. But for now, they are still together. All right, that will be that. So now you have these parameters here, and so I'll show you what happens if I edit them. So if I edit this to, let's say, 10 degrees, and I edit this to be 1 centimeter, 1 centimeter, and then I update it, you will now see that this does this. And now the beautiful thing about this system is that when I edit this to be 15 degrees and I press update, this will move, but this will remain in the same way relative to this point, this axis and this coordinate system, which is why it's quite an elegant solution to this otherwise rather complex way of setting it up. Otherwise, it would require a lot more math and a lot more setting up, but this way everything remains quite smooth. So I'm going to set this back to 0, and I'm going to set this one back to 0 as well, because we have to do this, of course, one additional time for the second flap. So we're going to do the exact same thing, of course. We're going to create an axis from a linear entity. We're going to select this trailing edge as a linear entity. Okay, then we are going to create a point by offset. We're going to select the same, in the same way, a point here. This time we're not going to forget the -1. Okay, and we're going to create another coordinate system by point and axis. So the point we are selecting is this one. Be sure to select the correct one, otherwise it will not work. And the axis we are creating is this, we're selecting is this one. And of course, don't forget to create it on the axis, otherwise your coordinate system will be on the point. All right, and then we're going to do one final coordinate shift from this one, coordinate system, to coordinate system number 2. That should be correct. All right, and in the same way, this wing has now found its way onto here. And we're also going to add an angle of attack transformation to this one. Transform, rotate in this coordinate system, 0 degrees, expose parameter to AOA. Okay, okay. And one more translation. Transform, translate. Okay, so now I have properly parameterized this. I will now off screen do the setup that I've shown in the previous video until the point where we have pretty much a running simulation. And then I will give a couple extra tips that will help, of course. If you don't know how to get to the point where I'm going to skip now, it's all explained in the previous video. Just follow the same steps. Thank you. All right, so I've set everything up now, as in the previous video, up till the point where we get to the meshing part. And I'm going to teach you a couple new meshing strategies you can use to improve your mesh quality. So firstly, what I'm going to do is going to teach you how to use volumetric controls. So for this, you need to actually create new parts, shape parts. So for this one, we're going to create a cylinder. We're going to be moving this cylinder. Oh, no, that's not what I should do. Hang on a second. To move this to 0, 0. And I'm going to make it so it's half a meter in radius, and then I'm going to make sure that it's minus 0.5, and here it's 0.5, right? And I'm going to move it a bit so it's in the center of this thing. So that means that this is at 0.2, probably 0.2, 0.2, and 0.2. This is still not ideal. I'll move it a bit more. 3, 0.3, and now a bit lower still. 1 and 0.1. All right, so this is quite okay. I'm going to increase the radius just a tad. Voila. That way we can create this, and then in the automated 2D mesh controls, we can add a new custom control, and we add volumetric control. And this volumetric control we are going to edit. We're going to select the part, and we're going to select cylinder 2, which is the one we just made. So you can see the second cylinder, and I can now make sure to select custom size, and that way right here I can select that the percentage is about 10% of the base, and then when I remesh, this mesh should be better. Yes, so what you can see, I have created this, but this is maybe a bit too much, so I'm going to change this custom size to about 50% of the base. So that might be a little too little. I'm going to turn it to 30, and there we go. All right, so this is now created more detail, but as we can see, these leading edges are still not ideal, not with any of them. So what we're going to do now is we're going to add specific smaller uh, volumetric controls to the specific regions that we wish to refine even more. So what I'm going to do is make a new volumetric control. I've already created one of these cylinders for the leading edge of the first wing, which is actually the easiest one. It's the one that doesn't move, it just rotates around here, and there will be no complex things to add to this one. So I'm just going to select here cylinder 1, all right, and I'm going to edit this value to be custom size. Let's say, yes, about 10% of the base. Let's see how this performs. That is still not enough. Let's make it 5% of the base. All right, so that at least adds more detail. It might still not be enough, so you can just go to 2.5, and in this way you can specifically increase detail at specific locations, such as the leading edge of your wings, without actually increasing it anywhere else where you might not need it. So right now, after this, I will show you how to make sure that this happens at these other wings in a way where they also move. I will show you how to parameterize that correctly. All right, I'm very sorry, my program had crashed and I had to redo some stuff. I should be back to, I'm even a little bit ahead of where we were, so I'm going to quickly run back through what I've been doing, and I'm going to do it one last time here. That way you guys also very much know how to do it. So, so the first thing you're going to need to do when you're creating these extra zones of detail is to create a bunch of parameters for every parameter that you are going to use. This is also necessary if you want to split the x and y parameters. So what you're just going to do is you're going to create new parameters, scalar, and once you've created them, don't forget to add a dimension. It's important that you specify this. So for example, your AOAs are angles and your x and y's are lengths. It's very important that you do this, otherwise it will not work. Then next, very important to keep your simulation working is to go into the design parameters right here and to edit these with these parameters you just created over here. So you'll, in this case, it'll just be a number with you, and you'll go here and you can just, so if I remove this, I'll just do, oh, and it shows up, and I just go flap 1 AOA, and that's it. Press enter, press OK, OK, close, and with the XY, it's the same. You will see this, and you can put these parameters in instead of the numbers that were just in. I'm sorry, like this. And this will make sure that when you change up these parameters, everything else will follow. Now here comes the part where we try to increase the detail around, for example, in this case, our leading edges. So you'll have these parts. You can go here and you can say new shape part, and you can create a cylinder. This enters this system where you create these cylinders. And I've already renamed mine. I've created one for the leading edge. This one doesn't move because the leading edge will always be at 0, 0, 0. So there's no need to do that. The one for the first flap, I've already parameterized and all. So I'll just show you quickly how that works. And then for the last one, we will still do it together. That way you can see the work that goes into creating one of these. So if I go to edit, you have this start coordinate and this end coordinate, which you can parameterize. And when you look at this, of course, it looks a little complicated, but in essence, it is just a little bit of trigonometry. So the x coordinate of this cylinder is simply the cosine of the first wing angle of attack times the chord length, which is 0.4 meters in this case, plus the flap x shifting. And of course, for the y coordinate, it is the same story, but with the flap y, and by taking the sine of the main wing angle of attack, right? So that just, you need to write this in here, you copy it, and then of course, very important is that you also need to put it here in the end coordinate, but of course, make sure that your z is 1 times positive, 1 times negative. That way your cylinder will be on both sides of your sheet. All right, so now we're going to do one last thing. Then, of course, when custom controls, you need to add your new volumetric control, and for example here, and then you need to select the place where you want this to happen, which is in case there's this leading edge variable, and then of course you can edit these values. So for the last one, we're going to make it together. That way you can see this process from beginning till end. And first, we have this flap 2 leading edge cylinder I have already created, but of course you can just create one yourself. I'm going to edit, and all right, here is where you need to keep your head a bit in the game, because now is where things get slightly complicated. So this is actually quite a useful environment where you can program truly lots of things. You can use this to program things like the lift coefficient and stuff like that. But right now we're just going to program this to follow this leading edge. Okay, so first we're going to need a cosine for this. We're going to need a cosine. The cosine is going to be of the main wing angle of attack. You're going to not forget to multiply it by its chord length. This is specific to the wing, of course. To that, you can add the flap 1x shift, of course. After that, you can add the cosine of the first flap angle of attack times its chord length, of course, 0.16. And you finish that by adding the flap to x coordinate. I'm just going to check whether this is already a valid. Yes, it sees this as a valid. Yeah, just make sure, because if you have to redo this completely, it can be quite a finicky thing. So I'm going to copy this and I'm going to paste this right here. I'm going to change the cosines to sines, and I'm going to, all right, in that way, I'm going to change these x's to y's. There we go. And I'm going to set this one to minus 0.5. All right, this should be correct. All right, yes. So then, if that is correct, you can copy it. And we're going to edit it also here, right? With the only difference being that this minus 0.5 will just be 0.5. So when you do this, so just to be clear, what we did here was just simple. Oh, I'm just sorry. What we did here was just simple trigonometry. So we just took the chord length of this, and to determine the x and y coordinates of this zone, which we're going to refine, we just had to do the cosine plus the shift plus the cosine plus the shift. So it's really not that complicated. Of course, you can always just control your work by seeing whether it aligns. And now the final thing we need to do is to add a new custom control. We're going to call this volumetric control. We're going to rename it to flap to leading edge. Right? It's always good to name things, because that way you can, when editing them later, then it's always easier to know what you're going to edit. All right, we're going to select the flap to leading edge, which we just put there. And we're going to make sure that we can customize the size further of these cells. I'm just going to check what value I used, 2.5. So value up, 2.5. And all right, as we have done this right now, when I remesh, there is increased detail around this zone. And the nice thing is that you can now, because you've created these all apart, of course, you only saw me create this one, but the main wing one is easier, as there's no movement, so no parametrization. And the leading flap 1 has a less complex formula, so just remove the parts where you add these lengths, and you will come to the same conclusion. As now you can see, I can edit these each separately. And of course, if I change the drastically change, I'll just change this to 10 centimeters as an example, and I remesh it. All of these follow suit, so it's quite nice. Of course, you can parameterize everything. You could even just make a calculation for uh, how long your wing is generally, and then change this big circle's circumference based on it. So you can really do a lot of things. You can even, I'm pretty sure, parameterize your domain to grow in size as your things get closer to it. You can make sure that the distance is always bigger than a certain amount and stuff like that. So uh, while it is a daunting tool, do be sure to take a look at it. And here's an example of one of the powerful things you can do with it. So instead of just having this entire circle be this detailed, we've just made sure that only the parts that actually matter. Of course, you could do the same for the trailing edges as well, but for now, we're just going to leave it as is. And from here, I will now teach you and show you how to use the design manager to actually run a couple iterative and different kinds of consecutive simulations. All right, so before you step into the design manager, of course, you just need a working simulation. So I've already done everything. You can see in the first video how to set up everything properly. But of course, just don't forget to set up your physics continuum. Um, do not forget to update your stopping criteria to the amount of steps you want to do. Make sure that you create reports. In this case, I just created a couple dummy reports, one for downforce and one for drag force. Um, Set up your plots in case you want any. I have one for the residuals, and I have one, I haven't renamed it yet, but it is the down force and drag force. And then set up a couple scenes. So just, you will, these are also just as an example, just to make sure that you know how to work in the design manager, because you'll be able to take, in a certain sense, you'll be able to take um, loggings and pictures of these. So just to be sure, I'll show you, this is a working simulation. I've set it up, I've set it up to where it works. Now, of course, whether it's accurate, that I have not spent too much time with, this is more to show you how the program actually works. The accuracy of the simulations is up to you to define by applying all the theory correctly. Um, right now, I'm just showing you how to use these tools, of course. So here are the monitors and everything. So also important before you go into the design manager is to clear all your solutions. Be sure that your um, simulation is completely empty, and then you go here, you right click, and you click create design manager project. All right, so if you click on that, it'll create a design manager project. This might take a while. So before we run it now, be sure to not forget to add the downforce and drag force to your responses. That is very important. And in settings, you can increase the amount of simultaneous job or the computing process. I'm going to increase the computing process to 12. Be sure to not exceed the amount of cores that your PC has, minus 16. So I'm putting it at 12. Check with your own PC. Usually PCs have 8 or sometimes more, but I mean, do not exceed the amount of cores that your computer has. So that way I'm going to put it at 12, and now I can press ready to run. Yes, I need to save before I run. I'm going to save this real quick. Save as. Listen to design manager project. All right, and let's go. All right, so once I press run, it's going to show in this output table all the designs it is going to test. When you change these design parameters later, these will remain here and it'll just keep adding to it. You can, of course, also create a new design study for a new parameter you want to check. But in here, you will see all these things. Now, of course, this is going to take a while. I will come back to you when that is done, but before that I'm going to set up a couple things so that later we can check the results real quickly. So I'm going to put the residuals and everything up there. I'm going to put the speed thing up here, and the drag and down force can be added here, and voila. In this way, once it's done, it'll be easy to check all the values. I'll see you guys back when these simulations are done. All right, now that's done running, you can see here all the results will be compiled here. You can export this information, of course, and by clicking on them, you can also just check the snapshots that were made for every single of the simulations. So here you can, if you want to check the specific airflow around um, based on the angle of attack, you can, and everything. Of course, this is not an accurate simulation in any way. This is more just to showcase how this part works. Of course, make sure to always at least try to validate these results in a way, or to ensure that you've taken proper precautions to ensure the accuracy of your simulations. You can take many more snapshots than the ones I've taken right now, and you can even take many more variables and everything. So this is just a simple way of showing you how the design manager works. Um, so I will end the lesson here for now. I will see you next week in lesson 3, where we will do some basic 3D simulations to move from 2D onto 3D. All right, thank you very much.